Okay, so now we're going to go over how do we find these inverses. So I'm going to tell you guys right now, the most important thing is what I told you in that first video. What's the most important thing to know about finding inverses of functions, or how you tell if a function is an inverse? You switch x and y. Switching x and y allows us to find the inverse. So, say I'm given this kind of crazy line, and it's got all these points on this line. Well, if I want to find the inverse, I simply need to switch x and y. So these 2 points will switch spots. So, -4 is an inverse. Switch your x and y. 0, -3 is an inverse. So down over here. Switch x and y. These 2 points just need to switch. 1, -2. 1, -2. Okay? Switch x and y. 4, -1. 4, -1 is the inverse. And you guys can see when you do that, again, these functions will be symmetric about that line. Okay? So it is as simple as that when you guys are trying to find the inverse. You simply need to switch x and y. 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 Okay, hope I said it enough. Oh, I guess I had all that up there. All right, here we go. So next then, what if I gave you an equation? What if I gave you an equation and said to find the inverse? What do you guys think we need to do? Switch x and y. Same rule applies. Switch x and y. Okay, so first step, I have y equals 3x plus 9. I'm going to switch my x and y. So I will have x equals 3y plus 9. Now what do you guys think I can do? Once you switch your x and y, you are simply going to solve for y. So the first thing I would need to do to get y by itself is subtract 9. Subtract 9. So that would give me an x minus 9 equals a 3y. Then I need to get rid of that 3, so I can divide both sides by 3. Okay? And honestly, you have an option at this point. You could just leave it as y equals x minus 9 over 3. Totally okay to leave it that way. If you wanted to, you could also make it a y and then x divided by 3 minus a 9 divided by 3. So you could also write this as y equals 1/3 x minus 3. Both of these would be completely acceptable answers, and I would not care one way or another which one you would end up using. Either one of them would work. Okay? But, so again, just to reiterate, how do we find the inverse of a function? Just switch it. Tired of yelling at you, Potts. Okay. Next one. Find the inverse for the equation of y equals 3/2 x cubed plus 6. Okay. Same thing. What's our first step? Switch your x and y. Common mistake, very common mistake that people will make on this. This is not correct. Okay? We are simply going to switch our x and our y. So the correct way to switch that would be x equals 3/2 y cubed. The 3 does not stay with the x. Okay? Just the x and the y will switch spots. Now again, once we switch our x and y, we are simply going to solve for y. So the first thing that I would do would be to subtract 6. And I get, oops, wrong color, my bad. I get x minus 6 equals 3/2 y cubed. Now I would need to get rid of that 3/2. So I could multiply by 2/3. multiply by 2/3. That would end up giving me a 2/3 x. And then 2/3 times 6 would get me 12/3, so a -4 equals just a y cubed. And when we need to get rid of the y cubed, we are just going to do the inverse of y cubed, which we will talk more about this probably around December. But the opposite of cubing a number would be to find the cubed root of that number. Okay, so I end up with a y equals the cubed root of 2/3 x minus 4. And probably the better way to write it would be with the y in front, just because that's how we are used to seeing it. Okay, so that is how we go about finding inverse functions. We switch our x and y. And there is one more thing that I want to cover with you guys, and that one additional thing is how do we prove that functions are inverses. So we already talked about how you can switch your x and y values to prove that they are inverses of each other. But we can also use our composite functions that we went over in lesson 5 too. So I can look at the inverse function composed with my regular function, or I can look at my regular function composed with my inverse function. Okay? And as long as everything cancels out and leaves me with an x, then that proves that your functions are inverses of each other. Okay? So in these notes area, kind of some layman's terms of it. Remember when you're doing composite functions, like if I have f open circle g of x, that means that I'm plugging my g function into my f function. Okay? So essentially what you guys are doing on this is you can either, and you only have to do it one way, both ways works. You can either plug your inverse into the original original function and simplify to x, or you can plug original function into your inverse. Either way will work, okay? So I can take my original function and plug it into my inverse, or I can take my inverse and plug it into my original. Either one should work, and when you do that, if they are inverses, you will get that it equals x. Okay? So, I about broke my headphones. So, on the next slide, we're just going to do two quick examples where we prove that. Maybe if I can get to the next slide. There we go. So, the one that we just found, okay, we tried to find the inverse of f of x equals 3x plus 9, okay, and we found that the inverse was 1/3 x minus 3, okay, so we can now prove, okay, so what I'm going to do is I'm going to do f open circle f inverse of x, okay, so simply put, I'm going to take my inverse function here, and I'm going to plug that inverse function into my original function. Okay? So I'm going to have 3, but then instead of x, I'm going to have 1/3 x minus 3 plus 9. So I took my inverse function, took my inverse, and I plugged it into my original. So when I go to simplify this, I end up with 3 times 1/3 gives me just an x. 3 times a -3 gives me a -9. A -9 plus 9, those two would cancel each other. And I end up with f open circle f inverse of x equals x. Okay, and what that does is that says, yes, they are inverses. And that's all we're doing this. We're just proving that they are inverses of each other. One more example. The last one that we did, y equals 3 halves x cubed plus 6, and y equals the cubed root of 2/3 minus 4. Okay, again, it does not matter which way. I always like to do the inverse, plugging it into the original. But just to prove it to you, we can do it backwards. So we can do f inverse of f of x. Okay, so now I am going to take my original function and plug that into my inverse. Okay, so I got a big old cubed root, and I've got 2/3, but then instead of that x, I'm going to plug in 3 halves x cubed plus 6, and then I still have my minus 4. So again, I plug this whole thing into my x there. Okay, so again, go through and simplify. First thing I need to do is distribute. Okay, so 2/3 times 3 halves, that's gone. It's just an x cubed. 2/3 times 6, that would be 2 times 6 is 12. And divided by 3 is 4, so that's a positive 4 minus 4. And again, all that is still underneath the cubed root. A positive 4 and a negative 4, those would cancel. So I'm left with the cubed root of x cubed. Okay, and we talked about that. Cubed roots and cubing of numbers is inverses of each other as well. So those two cancel out, so I end up with just an x. So again, f inverse, open circle f of x equals x. And that means, yes, they are inverses. And that's my answer. I'm just proving that they are inverses. Okay, you guys can see 2/3 and 3 halves cancel, positive 4, negative 4 cancels, cubed root, x cubed cancels. I'm left with just my x. And that's how we prove that those are inverses.